10th Physical Science, Lesson Chemical Bond, Topic Valence Bond Theory. Before this valence bond theory, we learned about the valence shell electron repulsion theory. So that cannot explain about the strength of covalent bond. But here, this valency bond theory explains the strength of covalent bond. To describe covalent bonding, a quantum mechanical model is called valence bond theory. For example, here hydrogen atom is there, second hydrogen atom is there. Both of them has a unpaired electron. One is upward direction and another one is downward directions. When these two unpaired electrons comes together, the atoms of hydrogens overlapping one another. Here we can see the overlapping the hydrogen atoms one another, and both of them have a opposite spin. One electron is upward direction and second one electron downward direction. So it can shows the opposite spin. Next, here we can see the single bond, hydrogen bond we can see here. Hydrogen atomic number 1, electron configuration 1s1. Another hydrogen atom, electron configuration also 1s1, electron configuration. So 1s orbital of 1h atom containing unpaired electron overlaps 1s orbital of other h atom containing unpaired electron of opposite spin, giving hydrogen bond and H2 molecule. Both hydrogen atoms share the electrons present between them. Here, two hydrogen atoms share the two electrons here, and the atoms of hydrogens overlapping one another, having a opposite spin, electrons seen here, and hydrogen molecules are formed in this position. So the covalent bond strength is depend on the overlapping of the orbitals. Next example, chlorine molecule. Chlorine atomic number 17, electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. It means p orbitals, how many electrons are there? 5 electrons are there. Okay, so only one unpaired electrons is there. This is a p orbital. First paired electrons are there, second paired electrons are there. In the last orbital contains unpaired electrons. Only one electron is there. Next one, hydrogen atom shape is round shape and p orbital shape dumbbell shaped. So this question is come in the S1 summative exams. Remember again the shape of the S orbital and p orbitals. So S orbital shape is round shape and p orbital shape is dumbbell shaped. And here first chlorine orbitals like this dumbbell shaped, and another chlorine atom has also dumbbell shaped. So first chlorine has a one unpaired electron and another chlorine has also unpaired electrons. But here we can see the opposite spins can be seen here. So when these two unpaired electron comes together between the two chlorine atoms, when the chlorine atoms overlapping one another, so the electrons shared by two chlorine atoms. Okay. So 3pz orbital of one chlorine atom containing unpaired electron overlaps the 3pz orbital of other chlorine atom that contains unpaired electron of opposite spin and form the chlorine Cl2 molecule. So here chlorine has a two unpaired electrons. First chlorine has an unpaired electron and second chlorine has an unpaired electron. So when the atoms of chlorines are overlapped one another, the unpaired electrons comes between the two chlorines. So these electrons shared by two electron atoms and form the Cl2 molecules. Next, formation of N2 molecule. Nitrogen has a atomic number 7, 1s2, 2s2, 2p3. Okay. Here we can see the unpaired electrons 3. Okay. So here two types of bonds formed between the two nitrogen atoms. First, when we can see the between the two nitrogen atoms, we can see that two different types of bonds formed between the two chlorine atoms. First one sigma bond and second one pi bond. Okay, sigma bond is very strong, and pi bond is a weak. Pi bond is strong, sigma bond is strong and pi bond is weak. And sigma bond is formed between the internucleus axis, and pi bond is formed between the lateral orbitals. When p orbitals overlap one another, then multiple bonds formed, like sigma bond, pi bonds. Sigma bonds formed due to orbitals overlap along the internuclear axis, and pi bond is strong. Sigma bond is strong. Pi bond formed due to overlapping lateral orbitals, and it is weak. Already we learnt about this. When two nitrogen atoms comes together, two types of bonds formed between the two nitrogen atoms. First one sigma bond and second one pi bond. The sigma bond formed between the internucleus axis and pi bond between the lateral orbitals. So sigma bond is strong and pi bond is weak. Next, here also we can see nitrogen atoms. Okay, so the orbitals are double shaped. N and N atoms comes together. So here, how is the electrons arranged in the p orbitals? First nitrogen has a electrons arranged in the p orbitals, and second nitrogen electrons arranged like this in the p orbitals. Okay, when the orbitals of nitrogens comes together and overlapping one another, the electrons are comes between the two nitrogen atoms and forms the sigma bond px and pi bonds pz and pi bond py lateral sides. Okay, so pi bond formed in the internuclear axis and pi bond formed in the lateral side orbitals. Okay, so in above diagram, nitrogen atomic number 7, 1s2, 2s2, 2px1, 2py1, 2pz1. It means p orbitals contains unpaired electrons 3. Px orbital of one atom, this one, overlaps the px orbital of the other n atom. N atom is nitrogen atom. Next, sigma px bond and px py orbitals of n orbitals overlap with other px py orbitals of nitrogen as pi bond py and pi bond pz. So nitrogen molecule has a triple bond. First one sigma bond, next one first pi bond and second pi bond. Totally 3 triple bonds formed between the two nitrogen atoms. Next one, formation of oxygen molecule. So two hydrogen atoms are there. Oxygen, first oxygen atom and second oxygen atom. Okay, so here also we can see the orbitals are overlapping one another and sigma bond and pi bonds formed between the two oxygen atoms. And electron configuration of oxygen 1s2, 2s2, 2p4. So here we can see the unpaired electron 2. So here we can see the orbitals of oxygen atoms overlapping one another and sigma bond can be seen between the two oxygen atoms, and pi bond also can be seen between the two oxygen atoms. Oxygen atomic number 8 has a electronic configuration 1s2, 2s2, 2px2, 2py1, 2pz1. It means unpaired electrons 2 is there. If the py orbital of one oxygen atom overlaps the py orbital of other oxygen atom through internuclear axis and formed pi bond pz orbital to pz orbital laterally, here lateral orbitals. Overlaps and forming pi bond pz. So oxygen has a double bond between two oxygen atoms. So here sigma bond one bond and pi bond second bond. Totally here we can see the double bond in the two oxygen atoms. Okay. So the sigma bond and pi bond shows the strength of the covalent bonds between the atoms of elements. All these about the valence bond theory.